video. So we are going to be doing the first section. And so this is section 1, 5.1, the unit circle. So the unit circle has a radius of 1, centered at the origin, and has the following equation: x squared plus y squared equals 1. And we're going to be using this for a lot of our trig, and so eventually it's very useful for this class to memorize this whole entire thing. And so 90% of all the homework will use these values and these points. And so here we have our degrees in our normal degrees. So this is what you guys will recognize. This is 30, 60, 90, which is a right angle, 120, 150, 180, which is just a straight line. And so this measures from here. So this is 30 degrees, and then from here, that's 120 degrees, 240, 270, 300, and 333. And also we have the same things, and this is also 0 degrees and 0. We also have the same thing in radians. And so what a radian does is it maps out degrees as well. So I can have pi over 6, pi over 4. There's a theoretical line here that you can't really see, right? Pi over 3, pi over 2, and most of the time we'll be using the pi's, and in calculus you almost always use the radians, because in calculus works better in radians than anything else. You can do it other ways, it just works better that way. And so we'd say this angle here is pi over 6 or 30 degrees. They're both the same, okay? These points along the unit circle just say what the point value is, and so I have 1, 0, so the x-coordinate is 1, the y-coordinate is 0. This is my first quadrant, this is my second quadrant, this is my third quadrant, this is my fourth quadrant, in case you forget. Some of the questions on the homework and the test will ask you, given an angle in what quadrant, so these are the quadrants. You can, or given a sign or something, and you can determine the rest of it. This goes up by pi over 6 each time, so this pi over 6, 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 and then pi over 4, pi over 4, pi over 4. And so this one each jumps in a successive order. Notice that these go in a very particular order. This is so it goes from 0, goes to half, square root 2 over 2, square root 3 over 2 to 1. Another way of thinking about this is 0 over 2 and then square root 4 over 2. And this will be 0 over 2 and then square root 4 over 2. And then you notice here that the x-coordinate goes down 1 in the square roots, right? Square root of 1, right? And then the y-coordinate goes up by this square root of 0, square root of 1 is 1, square root of 2 over 2, square root of 3 over 2, and square root of 4 over 2. So this is a quick and easy way to remember all that. So here's all the values. Of course, in the second quadrant, our x values are negative, our y values are positive. In our third quadrant, both values are negative and positive. Both values are negative. And then on our fourth quadrant, the x values are positive and the y values are negative. And then notice that these mimic the same numbers. And so this looks like this looks like this looks like this. Okay? So you're going to want to get this into your head. The next thing we have, let me zoom on in. And so it's going to say, show that this point's on the unit circle. So how am I going to show something's in the unit circle? Well, I'm just going to say it satisfies this equation, x squared plus y squared equals 1. So how do I do that? Well, here's my x, so square root 3 over 3 squared plus square root 6 over 3 squared is equal to 3 over 9. So we square both top and bottom here. Square both top and bottom here would be 6 over 9. So that's 9 over 9, which of course is 1. So this definitely satisfies this equation. For which point, find its y-coordinate. Well, here we can just do the same thing. So I have square root 8 over 3 squared. We don't know what y is squared, but we know this is equal to 1. We can move this all over. So we can square this, and so we'll get 8 over 9 plus y squared is equal to 1. Y squared is equal to 1 minus 8 over 9, which implies that y squared is equal to 1/9. That means y is equal to plus or minus 1/3. Okay, so that's how you can crunch through this. Terminal points. Terminal points is given a real number, t, you travel along the distance clockwise to a terminal point. These are called terminal points. Maps the T maps the same amount of radians. So notice here that this, say this is unit 1. If I went 3.14, right, I would go over to pi, right? And so that's pi radians. And so if I measure this distance here, that would be 1, 2, 3, and then 1.4. And so that's what a terminal point is. And so it's kind of like an angle. Your book makes it unnecessarily complicated for 5 seconds and then forgets about all of it. So just for this couple next homework sessions, just kind of deal with it. So when t is positive, we're going to go this way, around. Okay. Oh, I realized I didn't answer something on this. So find its y coordinate, but if this is in the unit circle of 4, we want to take the negative one. And so the correct answer here, sorry, I forgot to do this, is square root 8 over 3, and since it's in quadrant 4, we want the negative y value. Sorry, I just looked up and realized I didn't say that. Okay. All right. If I have a negative terminal point, or a negative t, we're going to go backwards, and so we go backwards on the unit circle. Okay, and we'll stop at some point of x comma y. Okay, and this will be at whatever point I stop at, p of some x comma y. All right, so let's actually map some of these out. All right, so find the terminal point for each of the given numbers. All right, and so what do we do here? All right, so here we're going to go backwards to minus, so this is negative, so we're going to go this way to pi over 4. Notice that this point is the exact same if I went all the way around to this point. Well, what is that? Well, we just look at our unit circle. Well, that's 7 pi over 4. Or another way would be to, oops, wrong one. So this is the same as 7 pi over 4, right? Or I could just take 2 pi minus pi over 4, and that will give me 7 pi over 4. So these give the same answers, and we just look around our little table here, we'll get this. So we have square root 2 over 2 and minus square root 2 over 2. So we'll just go ahead and plug that in. And so our p here is square root 2 over 2, comma, minus square root 2 over 2. And that's how you're going to solve these problems. So if I have this to be 2 pi over 3, means this is positive, it's just going to come here. That's the terminal point. That's the same thing. We look here. Oh, look, we have 2 pi over 3. There's our answer. Let's just copy that over here. Oops, one too many. And so here our point here would be minus a half, comma, square root 3 over 2. All right, so if I'm going minus pi, we'll come here and we'll end here. Notice that's the same thing as pi, and that gives me the value of negative 1, 0. Here, if I'm going 3 pi, I'm going to go around to pi over 2, and then once again back to pi. So I've actually gone around and come back. I'm ending here, and then once again is 0.4. All right, and so in order to, instead of going around and around and around and around, we're going to be using something we call let t be a real number. There's reference numbers associated with the shortest distance along the unit circle between the terminal point and the x-axis. And so basically, if you know the reference number, you only need to memorize this of the unit circle. Okay? Because what we have here, so this is 0 and 1, but if we know we're in quadrant 2, this would be negative 1, 0. Here, this is 3 over 2, this is negative 3 over 2. And so this angle and this angle are the same angle, right? This angle and this angle are the same, and they actually have produce, oops, this one will be this, and this produce the same values. All you have to then know is recognize when is x positive, when is x negative, when is y positive, when is y negative. And so the reference angles are super useful when calculating everything. So here we're going to say the reference number is t, so here we're going to go pi over 6, so let's go through this. So here we're at pi over 6, right? So we're going to come here, we're going to go around to here, and I'm saying this is 5 pi over 6, sorry, 5 pi over 6. Notice that the reference here would be this angle right here. And so this is the distance of pi. And so I'm going to take pi minus 5 pi over 6, and I'm going to get pi over 6. And so this is my reference angle. Okay, you have to do a little bit of visual math in your head. So here we have 7 pi over 4. If I map that, I come to here. Notice the reference angle would be the shortest distance to the x-axis, so this angle here. So this is actually 2 pi, because I'm going to take 2 pi minus this, and that will give me whatever this angle is. So 2 pi minus 7 pi over 4 equals pi over 4. Okay, let me write this for pi over 6, and then pi over 4. Okay. Alright, let's just do the last two. So here, we're going to do minus 5.8. So here we're going to go around here. And that's almost 2 pi, so it's somewhere here. Do I know what it is? No. But I know 2 pi is about 2.68. I minus out the 5.08, which will give me this angle here, which is my reference angle, or 5.80. That roughly equals 0.48. And then using calculations, which you don't know yet. So this was a bad example to show you, but basically type in sine and cosine. You can get the reference number. You get this point right here. And so this works with whole numbers, and that's the reason I showed it, even though you'll have to take it on faith that this is the value, the point value you get at that point. Okay? But you don't need to know the point value. That's not necessary. All you needed was the reference angle, which you can calculate, right? You can 100% calculate, so that's 0.48. Okay, and that's in radians. And here, if I have 29 pi over 6, so 29 pi over 6, so that's 29 pi over 6, well, that's the same thing as 24 over 6 pi plus 5 over 6 pi, right? And so I'm going to go around 1. So every 2 of these is 1 time around, right? And so I'll actually have, how many? I'll have this one. 24 over 6 is the same thing as 4 pi plus 5 over 6 pi. So I'm going to go around once. I'm going to go around twice, so that's 2 pi and 2 pi. And then I'm going to go around to 5 pi over 6. I'm going to stop right here. And notice that this is my reference angle. So it would be pi, because I want to take pi minus this, so minus 5 pi over 6. That's going to give me pi over 6, and so here my reference angle for this one is pi over 6. And so anything above 2 pi, you're just going to throw it away, because you're just going to go in circles either forward or backwards. You're going to find what this angle is, and then you're going to figure out which is the closest angle to it, and then do visual math. And just a real quick reference, if you land in the first quadrant, whatever that's the angle you're looking for, so whatever that'll be your reference angle. In your second quadrant, that's your reference angle. In your third quadrant, that's your reference angle. In your fourth quadrant, that's your reference angle. So that's which ones you're looking for. Standardly, you're going to throw away your powers of 2 pi. And then here, if you land here, you're good. It should just be whatever angle you have. If you land here, you're gonna, and you have to play, this little visual math game. Which way did I go, and what do I have to do to get this angle? Okay, so you're gonna be adding it or subtracting it from some value of pi, and that's it. That's the first set of notes.